So let's continue, okay? So the problem is always going to say something like, establish the following identity, blah, blah, blah equals something else. Establish this identity or show that the following identity is true, something like that. Generally, one side is more complicated than the other, okay? The way you do this is you start with one side and do manipulations you know are correct until it looks like the other side. And you almost always want to start with the complicated one and turn it into the simple one, because it is easier to simplify something than to complicate it. And some common things to do are, anytime you have sums or differences of fractions, change them into a single fraction by giving them a common denominator. It's frequently helpful to rewrite in terms of sine and cosine only. If the identity you're trying to end up with has tangents or whatever in it, then eventually you're going to have to go back to that. But that's okay. And always keep the goal in mind. What this means is you're not just blindly doing stuff and, oh, now I'm going to add 6 and subtract 6 because I can. That doesn't change it. And now I'm going to divide by pi over pi. Like, don't just make it up as you go along. You know where you're trying to get. You have a goal in mind. That really helps. Okay. So let's establish the following identity. Sine squared of minus theta minus cos squared of minus theta over sine of minus theta minus cos of minus theta equals cos of theta minus sine of theta. Great. Kind of a mouthful. So pick which side looks more complicated and then work your way towards the simple one. Gosh, that's a tough one. I think this is by far the more complicated side. So I'm going to start here. Now, bear in mind what you're trying to get. I know at the end of this whole problem, I should have this. I have no idea how to get there yet, but if I can get there, I'll be done. Leaving this blank space on the page, by the way, tells whoever's looking at it that you aren't claiming you're there yet. But even if you just wrote this, if this was a 10-point problem, you probably just got 2 points. You have indicated you know you want to start with one side and get to the other, even if you don't have any clue what to do. So I don't like having all these minus thetas in. If for no other reason than I don't want them at the end, there are no more minus thetas left. Also, minus signs all over the place, I tend to write them poorly and forget that they're there. So I'm going to use even-odd properties. Okay. So this is going to be the sine of minus theta squared minus the cosine of minus theta squared. I'm just rewriting that using the parenthesis notation. And then we're going to use even-odd properties. Okay. What can also be very helpful is leaving written notes as to what you're doing. So all we did now is rewrite sine squared minus theta as the sine of minus theta squared, etc. That's not really much of a step. It's just convenient. So let's look over here. Now let's use even-odd properties. The sine of minus theta is minus sine theta. The cosine of minus theta is just cosine theta. And the same thing in the denominator. And here we just used even-odd properties. Okay. Well, the numerator is going to simplify as just sine of theta squared minus cos of theta squared. That denominator, notice I have a negative on both. I'm going to factor it out. Okay. How would you explain to someone what you did? So imagine a classmate doesn't know how to do this problem, and you have to send them written work, and the goal isn't they just copy it and get credit. The goal is they actually learn something. How do you explain to them what you did? So all we really did was factor the denominator, a -1 from the denominator, and we simplified the numerator using the fairly obvious -1 squared is equal to 1. That's all. Okay, now let's go up here. I think we have enough space to finish on here. That numerator can now be factored as a difference of 2 squares. So this factors as sine theta plus cos theta, sine theta minus cos theta. And my denominator is still negative. sine theta plus cos theta. And we factored the numerator, and that was it. Numerator. Okay, I guess we did. Whoops, I just dropped. Sorry, I dropped my microphone. And I'm too lazy to record the whole video again, so you get to listen to that. Okay, so we didn't quite have enough space to finish this on one slide. Let me just erase some work. So just to refresh what we've done, we started with the complicated expression. All we did was rewrite this sine squared and cos squared in a little more easy to manipulate notation, used even odd properties, and then just simplified that -1 squared can be ignored, and factored a -1 out of the denominator. Then my numerator factors as a difference of 2 squares. So here's where we are, and we know this is where we want to get, but we're still not there. Okay, so what I'm going to do is I'm going to erase everything except where we started, where we know we want to end up, and where we've gotten so far. So for example, what we've already established with work that has now been partially erased is that this definitely is sine theta plus cos theta. I'm just copying where we ended off. Sine theta minus cos theta over negative sine theta plus cos theta. So we already know that's true. That's what we've gotten to so far. So let me erase everything else except where we're trying to end. I always want to remember where I'm trying to get. As convenient as technology can be, erasing is much slower than it is on the actual physical blackboard. Also, the whiteboards on campus allow me much more space. Like the whiteboards allow like 4 to 6 times more writing before we have to start erasing. Anyway, so here's where we are. Now observe that we can cancel off that term sine theta plus cos theta, leaving behind, sine theta minus cos theta over -1. And we just canceled sine theta plus cos theta over sine theta plus cos theta. Okay. And sorry, I forgot to erase this little bit over here. I'm not going to erase the bottom because we still know that's where we're trying to end up. That's the goal. Okay, we're awfully close. Okay, I would like to get down here with a cosine and a sine, and we have a cosine and a sine. It just looks like our pluses versus minuses are off, but notice that denominator is -1. So this is just minus sine theta minus cos theta, and that's just bring 1 over -1 as a -1 in the numerator. And now if I just distribute that -1, we get exactly what we wanted. So by doing a sequence of steps that are all individually legitimate, we started with this up at the top and managed to transform it into this. Therefore, those two things must be equal, provided that both sides actually exist. So let's see how the book does it. Presumably, it's all the same steps. Yes, the left-hand side is more complicated. So let's start there and start off with even-odd identities. Great. That's exactly what we started with. And then we used even-odd identities. We simplified that numerator, factored everything. This is exactly what we did. Canceled that off, and simplified that negative in the denominator. So they kind of combined a couple of steps into one, and we did it a little more step by step. But yes, this was basically the same steps. I'm actually checking because a lot of these problems can be done in multiple ways. This is not necessarily the only way you could have gotten from one side to the other. It just happens to be the way that is, I think, most apparent. And then the book and I both did it the same way by default. So let's try another. So pick which side is more complicated. Start with that and realize you're trying to get to the other one. Then start manipulating it using allowed steps and try to make it look like the other side. Okay, so pause here and try to do it, and then we'll come back and I'll present a solution. But remember, even if yours is different, it doesn't mean it's wrong. There might be more than one way to do it. Okay, so here's how I would do it. The left is definitely more complicated. I'm going to start with that. 1 plus tan u over 1 plus cotan u. And I know down at the end what I really want is a tangent of u. So what I'm going to do is I'm going to replace everything in terms of sines and cosines. 1 plus sine u over cos u over 1 plus cos u over sine u. Now I've got fractions within fractions, so I want to multiply this. Actually, I'm going to simplify the numerator and denominator. So I'm going to call this cos u over cos u plus sine u over cos u over, whoops, I forgot a u here, sine u over sine u plus cos u over cos u. Now I can do the numerator and denominator individually. This is cos u plus sine u over cos u. That's just the numerator. Now for a denominator, sine u plus cos u over sine u. Now I have one fraction over another, so I'm going to reciprocate the denominator. So this is going to be cos u plus sine u over cos u times sine u over cos u plus sine u. The cosine u and the sine u the cos plus sine term cancels, leaving behind sine u over cos u, which is equal to tan u, and we're done. Okay, so step by step, what did we do? We just used, let me switch pen color so that I can write down the explanations and it will be a little clearer. Okay, so just use the definition of tangent and cotangent to get from here to here. Here I'm just giving a common denominator, to both top and bottom. And then I'm simplifying that. And now I'm just reciprocating the denominator, simplifying, and then this is the definition of tangent. So that's how I would do this. Let's see how the book does it. It might be slightly different, it might be radically different, it might be exactly the same. Let's find out. Yep, start with that. Oh, okay, fine. So already they're doing it different. Totally fine. They're replacing cotangent with just 1 over tangent. Sure. Now they're giving a common denominator of tangent to the denominator. So the numerator, notice, is the same, 1 plus tangent. They've just replaced this 1 with a tan u over tan u. Okay, now if I reciprocate the denominator, it goes like this. Now we cancel out the 1 plus tan u and we just have tangent. Sure, maybe that's a little simpler, but not the way I did it. Doesn't mean my way was wrong. Okay, both of these totally correct. So the danger here, by the way, is I may do a version and you may do a version and your version might be different. It doesn't automatically mean that your way was wrong, but it doesn't automatically mean it was right either. So if you did it differently, if you're really confident because you've done a bunch of these and you know you're doing them right, that's fine. If you're still really shaky about how these problems go and you're doing them differently than the solutions in these videos, by all means, send in a picture or schedule an office hour visit or something and just check. Okay? Just because you did it differently than I did doesn't mean you got it wrong, but you should probably check that you got it right. All right, another example. Establish the following. So again, go through this checklist, pick which side is more complicated, and then maybe rewrite in terms of sine and cosine, maybe combine fractions, maybe do factoring or distributing, use trigonometric identities, who knows, but try to make it look like the other side. So pause here and try to figure it out, and then we'll come through it. I'll do it one way, and then we'll see how the book does it, which might be the same. So I don't think there's going to be any disagreement that the left-hand side is the complicated one. For whatever reason, when we in math write something like this, we tend to put the left side more complicated. I mean, they're equal, so whatever, but it's just like a mental thing. We tend to put the complicated one on the left so that as you read it, you get to the simple thing on the other side and you're like, ah, how elegant. Anyway, so I'm going to give these common denominators. Now the common denominator is just the product of the two. So this first term, I need to multiply by sine theta over sine theta. And the second term, I need to multiply by 1 plus cos theta over 1 plus cos theta. Now they'll have the same denominator, so let's actually expand everything out. We get sine squared theta over the product sine theta 1 plus cos theta, plus, if I FOIL out that numerator, it's going to be 1 plus 2 cosine theta plus cos squared theta, and then the denominator is the same. Now that they have the same denominator, I can combine them into one fraction. Okay. Whoops, I forgot the cosine squared theta. Good. Now I see a sine squared plus cos squared in the numerator. The first term is sine squared, and down at the end it's a plus cos squared, so I'm going to call that 1. I'm going to add it to the other 1 and just get 2. I can factor a 2 out of that numerator. Now I observe that the 1 plus cos theta can cancel, and 2 over sine theta is exactly 2 cosecant theta, which is what we wanted to end up with. Correct. So pause, double check that you can follow all of these steps. Then we will see how the book did it. I wouldn't be surprised if it's exactly the same. It's probably slightly different in 1 or 2 steps. All right, let's find out. The left side is more complicated, of course. Yes, so here they have given them a common denominator and just jumped right to that simplification step. If your arithmetic is good enough to do that, it's okay. When I write out my solutions, I tend to show every single step just so that we can all follow along clearly. But sure, this is giving them a common denominator and seeing what happens. Foiling out that 1 plus cos squared, yep. So regrouping, so they were very explicit about taking this sine squared plus cos squared and putting them next to each other. Okay, so observe where we are now, because it's going to flip to a new slide. And the way these PowerPoints go, it just starts fresh. So they're going to take this sine squared plus cos squared and replace it with a 1, which combines with that 1 to give me a 2. Factor out the 2, cancel those out, and you're left with 2 cosecant. It's exactly the same way I did it. Okay. How about this one? Tan v plus cotan v over secant v cosecant v equals 1. Again, start with the complicated side, do allowable steps, whatever that means, and try to make it look like the other. So pause here and try to figure it out. All right, hopefully you were able to do it. I'm just going to jump right to the book solution. There's not a whole lot of ambiguity about this one. Yeah, change everything to sines and cosines. We saw an earlier example where the book made it slightly faster by not doing that, but honestly, I always do it. The way I work through problems, I'd rather have lots and lots of sines and cosines, a smaller number, but more complicated functions. If I just have the same little bits to work with, I feel more comfortable. So change everything to sines and cosines. Now notice that numerator can be given a common denominator. So ignore the bottom. We're just looking at this bit here. The common denominator is going to be sine v cos v. So this has to get multiplied by another sine, and this has to get multiplied by another cosine. But hey, now what do I have up there? I have sine squared v plus cos squared v, which is just 1. Okay? And now I have 1 over cos v sine v over 1 over cos v sine v, so you can reciprocate that denominator term here, and now it kind of clearly cancels, and you just have 1. Hooray. Okay, let's do another one. Now here, it's not immediately obvious which side is more complicated than the other. Sometimes it's that way, so pick one and see if you can manipulate it to look like the other. I'll pause. Okay, so we've actually already done this one. It was one of the ones in the previous video at the very beginning, and it said start with the left and multiply by 1 plus sine theta. I think it was this. It may have been marginally different. So if you multiply the left-hand side by 1 plus sine theta over 1 plus sine theta, yep, everything works out. Now the question becomes, how would you know to do this? Okay. So we're starting here, and we know we want to get here. One of your most common things is using a Pythagorean identity. 1 minus sine squared equals cos squared, or sine squared theta plus cos squared theta equals 1. These pop up all the time. So looking here, what would I multiply by in order to make a Pythagorean identity show up? In the numerator, if I multiply this by 1 plus sine squared, my difference of squares factoring is going to kick in and give me exactly that. It's not the only thing you could do. Okay, so if I come all the way back here, let's say, and get rid of my pen marks, okay, what else could we have done in an effort to make a Pythagorean identity show up? Another option would have been multiply by cos theta over cos theta. Because now my denominator, my numerator is pretty ugly now. It's cos theta times the quantity 1 minus sine theta. I could distribute that out, but it's not immediately clear I want to. But my denominator is now cosine squared theta. Oh, hey, cosine squared theta, I can use the Pythagorean identity and replace that with 1 minus sine squared theta. Then I can do a difference of squares factoring in the denominator. 1 plus sine theta, 1 minus sine theta. These cancel, and we get out what we wanted. So that would have also worked. Okay, so again, there's no unique way to do this. But exploiting Pythagorean identities is a really, really common step. So we already saw this solution. And that's the end of this. So just practice a bunch of these. Come by office hours to ask. This section, establishing trigonometric identities, is a pretty important one. It's where you start really working with mathematical reasoning rather than just solve and get a number. You're trying to logic your way through why two things are equal. It's a very fundamental part of what math is. And it's kind of new. It's different maybe than what you're used to doing. So if you're having trouble with it, please just come to office hours or email me to ask for help. We'll figure it out. Most students find that if they put the effort in, these problems start to become very routine, and it's like a good way to quick get credit on exams. Other students just sort of shrug and say, LOL, I don't know how to do this, and they leave them blank, and then they fail the course. Okay? So don't be that person. Be the other person who seeks help, who practices, who does problems and works through it and manages to get it in the end, and then these become pretty straightforward.